scientists have found what they think is the engine that powers Jupiter's jet streams. They identified a region of extreme cold at the planet's poles, which could be a key part of this process. But there's still one question scientists can't answer. What exactly is powering these intense storms? It might not be what you think. Welcome to my channel. Join me today as we explore the strange world of our largest gas giant and take a look at the incredible discovery that might finally explain where the energy for Jupiter's most powerful storms comes from. We know quite a lot about Jupiter. After all, it's been studied for centuries. Since Galileo first observed the planet through his telescope in 1610, we've sent several spacecraft out to meet it. And it was worth the trip because Jupiter did not disappoint. The probe Juno, launched in 2011, arrived at the planet in 2016 and has been orbiting it ever since. Some of the things it has revealed are truly remarkable. Juno found that Jupiter's jet streams blow at speeds of more than 400 miles per hour. That's around 640 kilometers per hour. These winds are so strong that if they hit you while you're standing on Jupiter's surface, you'd be blown away before you even had time to blink. This makes them the strongest winds in the solar system. In fact, they're so powerful that if they hit you on Jupiter, you'd be utterly crushed into a pancake. And it's not just how fast these winds blow, they also last an incredibly long time. They can go without stopping for hundreds of years. Imagine living through a storm longer than your entire lifespan. Well, if you lived on Jupiter, you would need to. That's how long these storms last. But that begs the question, why do they last so long? And more importantly, where does the energy come from that sustains them? These questions have stumped scientists for decades. We're used to winds on Earth being driven by differences in temperature, warm air rises, and cold air sinks. When it reaches the poles, it starts to spin, creating the polar jet stream we see there. It's the same story at the equator. There's a band of warm air rising there too, which creates another polar jet stream, but heading in the opposite direction. But on Jupiter, the situation is very different. The energy driving the planet's winds doesn't come from the sun. Instead, it seems to be fueled from deep within the planet itself. Scientists believe this because the energy powering Jupiter's winds is way too intense to come from such a weak source as the sun. The radiation coming from the sun isn't nearly enough to explain how the storms get their energy. So, something else must be going on here. One theory is that it comes from the planet's core. Scientists think Jupiter might have a solid core hidden beneath all of its gas, although no one has actually seen it. If it exists, this core could be made of rock and metal, and it might be big, too. Estimates suggest that it could be anywhere from 10 to 30 times larger than Earth's core. And it could be generating huge amounts of heat as a result of gravitational collapse. That heat would then fuel the powerful winds we see raging across the planet's surface. If that's true, though, there should be some way of detecting this heat. Unfortunately, Juno hasn't found any evidence of that. Or maybe the energy powering Jupiter's winds comes from its metallic hydrogen ocean. Metallic hydrogen is a strange state of matter that only exists under extremely high pressures. And Jupiter's atmosphere has plenty of that. It's thought that when hydrogen is squeezed by the immense pressure of a gas giant like Jupiter, it loses its insulating properties and becomes a great conductor of electricity. This metallic hydrogen sea could be wrapped in a thin layer of non-conducting hydrogen gas. The friction created by the winds blowing across this boundary would generate electrical currents. These currents would then create magnetic fields, causing an immense amount of energy to be released. Scientists believe that this energy release may be responsible for powering Jupiter's storms. If either of these theories were true, it would explain why Jupiter's storms are so powerful. But again, there's no sign of this happening. So, scientists have been left baffled for decades. That is until recently. Thanks to Juno's observations, scientists have now been able to track what happens to the energy released by Jupiter's storms. As the energy moves away from the poles, it causes the atmosphere in that region to cool to incredibly low temperatures. Using data gathered by Juno, scientists were able to identify a region of space around Jupiter's north pole that was colder than the surrounding area. This suggests that some kind of energy is being lost from the atmosphere there. The question is, where is it going? To answer that question, researchers created a computer model of Jupiter's atmosphere. They wanted to see what would happen if they simulated a storm at the planet's north pole. The results were surprising. Their simulation showed that if a storm formed at Jupiter's north pole, the air would rapidly cool. This cooling effect would then spread outward, creating a visible dark spot on the planet's surface. And that's exactly what Juno saw. What's more, the cooling effect in the simulation was caused by a drop in temperature in the stratosphere. This is the upper layer of the atmosphere. And it means that whatever is causing these storms is drawing energy away from the atmosphere and releasing it somewhere else. But where? It's possible that the energy is being drawn down into Jupiter's interior and released there. If that's the case, it would help to explain why the planet's core hasn't cooled down yet. Or maybe the energy is being converted into heat by the metallic hydrogen ocean. If that's true, the heat might be leaking out of the atmosphere and warming up the surrounding space. Now, this is just speculation based on the data currently available. More research needs to be done before scientists can say for sure what happens to the energy released by Jupiter's storms. In the meantime, though, this discovery has helped to solve one of the biggest mysteries surrounding Jupiter's atmosphere. And it's given us a new perspective on the planet's most famous feature, the Great Red Spot. As we all know, the Great Red Spot is a massive high-pressure storm that has been raging on Jupiter for hundreds of years. But we don't know much about it because it's so far away. Trying to study such a distant object is like trying to examine the surface of the moon with a 100-year-old telescope. That's why the discovery of a similar storm at Jupiter's north pole is so important. By studying this storm, scientists hope to gain new insights into the Great Red Spot and other similar storms around the planet. What's more, they'll be able to study it in greater detail than any other storm in the solar system. So it's a win-win situation, but there's still one question that remains. What exactly is fueling these powerful storms? And it looks like scientists are no closer to answering that question than they were before. One thing we do know is that these storms are powered by some kind of energy engine. And that engine appears to be located near Jupiter's poles. What's more, this engine seems to work in a similar way to the engines we use on Earth. An engine takes in fuel and releases it as energy. And that's exactly what's happening on Jupiter. The engine sucks in hydrogen gas and releases it as energy, creating the powerful winds we see. But that raises another question. Where is the fuel coming from? And more importantly, why does it only occur at the poles? One theory is that the fuel is coming from Jupiter's core. This would make sense because the core is thought to be the engine's fuel tank. As the fuel is released, it would create a cooling effect, which would then spread out through the atmosphere. This would explain why the engine is always located near the poles. Unfortunately, there's no real way of testing this theory. But scientists are hopeful that the next spacecraft to visit Jupiter will be able to provide the answers they're looking for. For now, though, we'll have to wait and see what the future brings. Will we ever really understand what powers Jupiter's engine? Only time will tell. So what do you think? Does this engine really exist? And if it does, what's powering it? Let me know in the comments below. And don't forget to subscribe for more videos about Jupiter and the other planets in our solar system. Thanks for watching.